it only moves it one way, then pitch up and down. And now do collective. Collective is on the left. Yeah, pull it up. And that changes the raises the pitch. If you pull it up, that gives you more lift.
Is that the fixed wash plate? Is that the collective?
This is the part here that doesn't rotate is the fixed swash plate. The part that rotates is the rotating swash plate. So do that again while I'm spinning the rotor and watch. See, the fixed swash plate doesn't rotate, it can't. But it transfers the motion to the rotating swash plate, which then transfers the motion, and it's different for each blade. As each blade rotates, it's constantly changing its pitch. And that's how we get the control that we need out of the helicopter. So a bit more complex than a fixed wing airplane. And you've got to lubricate all these pieces. So there is more maintenance involved. You've got lubricant inside the transmission that you have to maintain the proper level of. So there's seals to keep that in there. You can see where the linkage come from below the cockpit into transfer through these links into the pitch change links.
That blade struck the top of the wing.
Oh, it did?
Just scratched it a little.
Oh, okay.
Not that. I guess.
Yeah.
Because you're good.
Okay. Okay, don't worry about it. Huh? That's usually a trim switch. And this would usually be the radio switch. So this is like it drives the electric trim that drives one way or the other. So you can pitch, trim, and roll trim. It drives an electrical actuator.
You have to hold it at the same.
No, you just push it over and it changes a little bit. As long as you're holding it, actually. And I think this may be the mic.
It's the gun switch.
No, there's no guns. Yeah, because you got your hands full. I mean, you got your feet controlling the yaw like you do in an airplane, and you've got one hand controlling the pitch and roll, but the other hand in an airplane, you're normally controlling throttle, but you set the throttle and you change it once in a while. But in this airplane, you've got to control the collective. But the collective also, there's a knurled knob around here that you can lock the collective in position so that once you get to if you're cruising, you can lock that and then you can let go of it. But that will lock it in position. It's only on the pilot side. Well, it's actually on either side can reach it, but that's so you don't have to hold it. So you do have a free hand sometimes when you're flying. But if you're doing anything other than straight and level, you've got both hands and both feet working just to control the helicopter. So it's more pilot intensive and more difficult to fly.
Is that like a horizontal stabilizer?
Yeah.
And that's good.
Yeah. Yeah. So if you over rotate, if you didn't have the skid there, you'd hit the tail rotor and destroy the tail rotor and lose all yaw control.
How does the horizontal stabilizer work?
It's fixed. It's just to provide stability. And I noticed there's a stall strip on it. I'm not sure exactly the aerodynamics here. Stall strip with leading edge, just to manage the airflow. I'm not an expert in helicopter aerodynamics, nor do I care to be. They're interesting machines, but I'm more fixed my guy. Yes.
Do you know who trained with this
Army.
Army?
Yeah.
And
It was developed as an Army trainer.
was it using the Korean War? Or I mean to train for
It was after the Korean War. It was built in the early 50s. After the Korean War. The Korean War ended in 53, 52, 48, 52, 53. So it's just post Korean War. pre-Vietnam. And really, helicopters didn't, a few of them entered service in the late stages of World War II. They came into the room primarily being medevac in Korea. Actually, I'm not sure if it's still true. At one point, the Army had more aircraft and boats than the Navy because the Army has a ton of helicopters. There's something written into the legislation that says the Army is not allowed to operate fixed-wing airplanes. So in many cases, fixed-wing airplanes for some of their missions would be better, but since they don't have a choice, they have to fly helicopters. They use helicopters for some missions more suitable for fixed-wing. And they've got a lot of small boats, so they've actually got more boats than the Navy has, but of course they don't have ships. The Navy's a lot of ships.
They used to though, right? Yeah, they used to fly this way.
Yeah, they used to.
Like the caribou.
Yeah. Of course, the Air Force used to be part of the Army. It was the U.S. Army Air Corps. Came a separate service in 1947, post World War II. So World War II, the Army was the one doing the volunteer fighting, as well as the Navy. And the Navy has their own armies called the Marines.
Did we actually get this helicopter from the Army?
I'm not sure. That some of these wind up in private hands. We got it donated from somebody else. I don't know who. It was before my time. It was donated sometime between when I was a student and when I started teaching. So I'm not sure when. Because the only helicopter we had when I was a student was that Pillar ramjet powered. Which may be the one that's in the Miller Museum now, I'm not sure. One of my professors at the time was the chief aerodynamicist at Hiller, and he only taught one class a semester. He taught the upper division aerodynamics series. So, chief aerodynamicist at Hiller. Hiller used to be a pretty big aeronautics company. So play with it as much as you want, and then we'll go in and.
What is that? This link to
What is what?
that link?
This?
Or the one behind it? Or
This? That, I'm not sure.
How about this?
I don't know what this is. It may be. Yeah, but I think it's electrical, because it looks like an electrical connector. I'm not sure. And of course, these are all fixed. This is aluminum tube with, and you can tell that these are riveted on. This is an aluminum tube with the ends wedged down and then riveted to a connector to join this together. Whereas these are steel tubes. If you had a magnet, you can prove that, but these are welded. You don't normally weld high strength aluminum because it doesn't weld very well. Something we'll talk about materials that when we finish the vertical flight stuff.
Is that the gearbox right there?
This is, yeah, the transmission or gearbox that takes the power. There's a series of V-belts, and you can disconnect. There's a lever to disconnect the power so you can run the engine on the ground without the rotor spinning. And then the V-belts go up from the engine output here into the input into the gearbox or transmission, more correctly, transmission, that then drives the rotor as well as has the power takeoff to drive the tail rotor at about 1/10 speed of the main rotor. So everybody has everything they need? You all know how this works now? And you can explain it to me. Good, then everybody's gonna go 100% on the lab. Okay.
すみません。